Welcome viewers, if still you're not subscribed to this channel, kindly subscribe and also click the bell icon to get technology updates regularly on this JP Infotech channel.
Hi, in this video we are going to see about a Python project which is entitled as Liver Disease Prediction using Ensemble Technique, which is an IEEE 2022 conference paper. So before seeing the execution of the project, let me brief about this project. Basically, the liver illness or the liver disease is one of the worst disease on the planet. Why? Because the liver is the important organism in the human body, because the liver's main function is to eliminate the waste created by the organism. So if there is any problem or illness is created in the liver, then this waste will not go out and also it will not digest the meal. So this is a terrible disease. So the only way is to limit the disease, or the early detection can save the organism. So the amount of people that are affected using for this liver disease is around 3.5%. So there are a number of advancements coming in the prediction of the disease using the machine learning classification technique. So here in the base paper, the authors have used the ensemble technique. So what does this ensemble mean here is like it is a combination of two or more models. So basically we have seen that we would have used a single model for predicting any kind of diseases earlier, but here in this ensemble technique we will be using multiple models here. So here you can see the ensemble techniques are a model that are created in multiple and are combined to get the good results here. So here the authors have used the ensemble technique and they have used such as random forest, SGBoost, gradient boost and are combined to get the greater accuracy. But we are not going to use the same as mentioned in the base paper. So as our proposed, we'll be improvising the model using the gradient boost classifier plus AdaBoost classifier. So the ensemble technique that we have used, the combination of the gradient boosting classifier and the AdaBoost classifier, and the training accuracy that we have achieved is 100% and the test accuracy that we have achieved is 92%. And now let me show you about the data set. So here in the data set you can see the features such as ID, age, gender, total bilirubin, direct bilirubin, alkaline phosphatase and alanine aminotransferase, asparated aminotransferase, total proteins, albumin and globulin ratio, the data set, and this consists around 583. So before executing the project, make sure that you are satisfied the requirement that is mentioned with the exact version of the Python, the libraries that is mentioned. So first copy the source code location. Now go to the command prompt. Now go to the source code location, type python app.py and click enter and wait for a few minutes. Now you can copy this URL, go to any of your browser. I'm going to Firefox, just paste this URL and click enter, and now you can see the home screen or welcome screen of the project with the project title liver disease prediction using ensemble technique. Now just click this login menu. So now it will be navigated to the login page, and this is a static login page because we have not used any database in the project. So just enter the default username and password as admin and then click the login button. So once the login is successful, it will be showing login success and click OK. Now it will be navigated to the upload part where you need to upload the data set. So they just click the browse button. Now you can go to the source code location where you can find the upload.csv. Just select it and then click upload. And once the data set is uploaded, it will be navigated to the preview part where you can preview the data set that we have uploaded. So here you can see the features that we have already discussed, that is ID, age, gender, these details. So just you can scroll down till the end of the page. and you can find the complete data set is being loaded into the preview part. And now you can click the button, click to try not test. And after a few seconds you can see training finished message and click OK. Now it will be navigated to the prediction part where we need to enter the test case to predict the whether it is a disease or no disease part. So first let me enter a case with the age of 65 and gender as female, total bilirubin as 0.7, direct bilirubin is 0.1, alkaline phosphatase is 187, alanine aminotransferase is 16, aspartate aminotransferase is 18, total proteins is 6.8, albumine is 3.3, albumine and globulin ratio is 0.9. And now let me click the predict button, and now you can see the prediction result is positive, that is liver disease. And now let me show you with the other case. I'll enter the details: 17, age and gender male, total bilirubin is 0.9, direct bilirubin is 0.3, alkaline phosphatase is 202, alanine aminotransferase is 22, aspartate aminotransferase is 19, total proteins is 7.4, albumin is 4.1, and albumin and globulin ratio is 1.2, and click predict. So now you can see the prediction result is no disease. Let me show you the other case. 10.9, 5.5, 699, 64, 100, 7.5, 3.2, 0.74, and then now let me click the predict button, and the prediction result is positive, that is liver disease. And finally let me show you a final case with the age of 64, gender as male, total bilirubin as 0.9, direct bilirubin is 0.3, alkaline phosphatase is 310, alanine aminotransferase is 61, aspartate aminotransferase is 58, total proteins is 7, albumin is 3.4, and final albumin and globulin ratio is 0.9, and the prediction result is no disease. So I have shown you few cases from the data set of the test cases. You can check with the other scenarios from the test case results, or you can check with the data set that we have trained up with. So now let me move to the next part, that is the performance analysis part. In the performance analysis part, we can see the performance analysis parameters like recall, F1 and precision values. So here you can see the recall, F1 and precision values with the positive and negative cases, and also you can see the confusion matrix with the true and the predicted results of it. And final comes the chart part, and this is the chart. So this chart is a static chart. This is not a dynamic chart because we have not used any database in the project. So this chart has been predicted from the dataset that we have trained up with, so which consists around 40% of liver disease data and also 60% of no disease data from the dataset that we have trained up with. And now let me log out, and this is all about the project liver disease prediction using Ensemble Technique. And thank you all for watching.